Okay, I'm going to lead with recording. I'm going to lead with the quiz, reviewing, revisiting, hopefully learning something from mistakes, because I don't want to forget this at the end. And then we're going to get into just as much applying to acceleration as possible, doing applications. This is your first time with acceleration, so I'm going to give you more hints about how to do stuff than usual. We're going to continue acceleration all next week. I mean, both days next week and build from here. But this is your first time seeing, so I'm going to give you more upfront today than usual. All right, anyway, we've got a position versus time graph. I want to emphasize again, position time, velocity time, acceleration time graphs, they are all different. So how do we interpret the direction of motion? We look at, is he slopey uppy, is he slopey downy? I am moving in the positive direction. I am not moving. I'm moving in the negative direction. I'm not moving. This is the only positive slope. Correct answer is A. Again, on a position graph, the direction of motion is, are you slopey uppy or are you slopey downy? Speed, when are you at rest? At rest is the slope, at that instant at least, horizontal. Here is moving, here is not, neither moving forward or backwards. Here is moving in the negative direction, negative direction, negative direction. Here is not moving, correct answer BF. If you're looking for speed, you're looking for tiltiness. And at B and F, no tilty-tilty. That's the technical term for it, yeah. True or false, it is possible to have zero position and negative velocity. Position tells you where you are relative to your defined origin. For instance, my favorite example for now, I'm going to define this tabletop as x equals 0. So here's x's positives, x is big positives, x is small positives. Here's x is a small negative, big negative. Yeah. Negative velocity means position is going down. Here's a negative velocity. Here's a negative velocity. Here's a negative velocity. Positive velocity is going up. If the absolute value, if the magnitude of velocity is big, that means fast. If the absolute value of velocity is small, that means slow. So, question, is it possible to be passing the table surface while moving downward? Sure, at that instant. Now, that instant, I was moving down while passing the horizontal, or while passing the origin. Let me flip it around. Is it possible to have zero velocity and negative position? What do you think? Google form, G. Yes or no? Do you think it is possible to have what? Negative position and zero velocity? Does that? Okay, chop chop, quick think about it. Let's see. Great. Everybody who voted yet got it correct. No, not everyone. 95% of you got it correct, though. Here is something at positive position. Here's something at negative position. Here's something moving slowly. Here's something moving quickly. To be at negative position with zero velocity, I'm demonstrating right now. My hand is below the axis, below the horizontal. For God's sake, below x equals 0 and not moving. Let me follow this up. Is it possible to have positive velocity and no acceleration? Google form, what are we at? H, positive velocity and not accelerate. This will be on your next quiz, I think, or exam. Yeah, I forget. Is it possible to have a positive velocity and zero acceleration? Acceleration is how fast velocity changes. Is it possible to have a positive velocity and zero acceleration? Zero acceleration. Acceleration is the slope of velocity. Correct answer is yes. Here, I'm moving with positive velocity and I am not accelerating my hand. Lastly, question here, is it possible to have an acceleration when velocity is zero? Question I, what do you think? Is it possible to have an acceleration when, at least for an instant, when velocity is zero? Is it possible to have velocity zero and acceleration non-zero? Almost everybody says no. The relationship between velocity and acceleration is the same as the relationship between position and velocity. Velocity tells you the rate at which position is changing. Acceleration tells you the rate at which velocity is changing. Let me ask you, can you have position zero and velocity non-zero? Sure. Now, my hand was moving through the origin, and moving through the origin, at the origin point, and had a velocity. Its position was changing, even though its position at that instant was zero. I'm going to say now, when my acceleration is non-zero and my velocity is zero. Now, at that instant, I was not moving, but I was changing my velocity. Now, a turnaround point has, at least at that instant, you're not moving. I was not moving now down, nor was I moving up. I was just stopping moving down. I was just starting to move up, right? So that was an instant where I was turning around. I was changing my velocity. My velocity was not staying the same. My velocity was not staying zero. I had an acceleration, but not a velocity. You will find that every permutation, every combination of zero acceleration, positive position, negative velocity, zero acceleration, blah, 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 velocity, blah, 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 acceleration is possible. They all correspond to different kinds of motion. You will learn, you must learn, if you want to pass the test, you will learn what these things mean and be able to connect them to common sense, how you would describe it to a 5-year-old or whatever, as I say. Anyway, question 4, last one. By definition, slope of position versus time is velocity. Got my brain on our current module, current day. So by definition, the rise over run of x versus t, the delta x over delta t, change in position, displacement per time interval, that is the meaning of velocity. Okie dokie pokey pony? Questions? Give me a question. Oh, for dog's sake. No. Here we go. Yeah. Questions? About the quiz? About life? Any administrative BS? BS for me is defined as anything which is not teaching you physics. Talking about the class. May be important, but it's not physics, so I care less about it. Okay, so let's dive into acceleration. Let's talk about, first off, let me give you a brief look at what the defining idea behind acceleration is, and then I'm going to demonstrate more examples than usual. I think this is, based on prior experience, harder than velocity and position. So I want you guys to have a fair number of big fat hints for the homework, ideas of how to do stuff. Okay, so what are we? September, read it first. Set 3 lecture notes. Acceleration, A, is defined as have I talked to you guys about the triple equal? This is my notation for definition. A triple equal is always true. Always universally true. It's the meaning of this. The term on the left and term on the right are synonymous. For instance, Dr. Tucker, triple equal funny. I'm the definition of hilarity, right? Dr. Tucker is currently equal to teaching, but that's not always true. Yeah, that is something I'm doing at this time, but may later not be true. Teaching is not my meaning. Funny is, what I am intrinsically. Where delta V represents a change in velocity. And delta T represents a time interval. Represents, I can spell. How do we measure V's? How do we measure velocities? Oh, come on. How do we measure velocities? What are the units? The default SI units. Bada bing, bada boom, meters per second. In imperial miles per hour. Bleh. Meters per second are your default units. How do we measure T's? You big T's. Seconds. Acceleration can be measured in terms of meters per second. Or, if you don't like compound fractions, meters per seconds squared. Meters per second, each second, meters per second squared. And how I think of this, I can't think of squared seconds. I don't know how to interpret that in my brain. But how I think of this is meters per second is the quickness of motion and direction. How much does that change in each second? If I'm accelerating at 5 meters per second, then in each second, my velocity changes by 5 units, right? If I'm accelerating at negative 5 meters per second, each second, my meters per second is changing by -5, yeah? That's how I interpret, that's how I think of it internally, the units. Okay, I should properly be putting vector hats on these. Acceleration is a vector. Acceleration has a direction. You can accelerate up, you can accelerate down, left, right, in, out, forward, backward. And these have a different effect on motion. I want to emphasize something muy importante, very common goof. Write this down. Negative acceleration is not deceleration. Acceleration is a vector. You can have plus minus. Negative acceleration does not mean slowing down, necessarily. Could, but not always. If you are slowing down, you might have a positive acceleration. You might have a negative acceleration. It depends, and we'll see later on what it depends. Very common goof, though, is to think plus and minus refers to speeding up, slowing down. I do not like the term deceleration. It is a very common English word. I do not like it because of this common goof. I prefer to be very picky about my language, and when something is speeding up, I say speeding up. When I mean slowing down, I will say slowing down. You never have to wonder if I mean accelerating as the speeding up one, because I never use it that way. I use acceleration as the acceleration vector. or sometimes as the magnitude of the acceleration vector. What's the magnitude of velocity called? Absolute value? Speed. There is no word for the absolute value of acceleration, which sucks. If I want you to answer a question where you give me the absolute value, the magnitude, the size of, if you will, the acceleration vector, I will ask you specifically for what is the magnitude, and I would never give you a question where I ask what is the magnitude of the acceleration and give you negative numbers to trick you. Physics is tricksy enough. I do include questions that are subtle, which many people say are trick questions. I include questions which are subtle. So I'm not going to do something like that to you. So acceleration, deceleration does not correspond to positive and negative acceleration. I suggest you take the word deceleration out of your physics vocabulary and refer to it as speeding up or slowing down. There's actually a third way you can accelerate too. I just demonstrated it. Anyone know? Turning around is also a form of acceleration. Later in the semester, we may, depending on how y'all are doing with the other stuff, discuss how turning in a circle is also an acceleration. I'm accelerating my finger right now. The direction of motion of my finger is changing and changing steadily. This is not a constant velocity. There is an acceleration associated with circular motion. We may or may not get there. On a graph of, I'm almost done, by the way, with the theory. We're going to talk about implementing this in a second. Velocity. We see acceleration as slope. What's the formula for acceleration that I just said? Delta V over delta T. The rise of velocity versus the run of time, right? Rise over run is slope. So the slope of velocity is acceleration. I want you to be very careful. You have been dealing with position graphs a lot in the last, since the semester started. We've been dealing a lot with position graphs, and you have hopefully memorized, learned, understood that slope of position, how rapidly position changes, rise of position displacement over run of time, tells you velocity. It is not always true that slope is velocity. Slope of position graphs are velocity. Slope of velocity graphs are acceleration. So if you've memorized slope is always velocity, you're wrong and you will miss things. Go back and think about this. The change in the vertical coordinate is different on different kinds of graphs. So you can't always say slope is this or slope is that. It depends on what you're talking about. On a graph of position, we see acceleration is curvature. If you have a curved position, you are always undergoing some acceleration. If you have a straight, linear, which could be diagonal or horizontal, line on position, something which is not curved, which is along a line, there is no acceleration. How do you calculate? What's the formula for curvature, anyone? That's right. For you, there is no formula for acceleration. I will never give you a graph of position and ask you to calculate the acceleration directly. Merry Christmas. You need calculus for that, and this is not a calc-based class. If you've taken calculus and wish to know, see me for office hours. With calculus, it's not hard, but without calculus, it's impossible. Yay! Okay, so turn to your neighbors real fast and tell them 3 facts about acceleration. Real fast. Negative. Okay, time's up. As you explain to your neighbor, you very often find out that, yeah, something didn't quite click. If that is the case, or if your neighbor is explaining to you and you realize that what they're saying doesn't sound quite right, there's something missing. Ask me. Ready, set, go. Ask me right now. Raise your hand and ask me, or just scream it out. Yes. Yes. And here's an example. If I turn around while moving downward, here's negative velocities becoming positive velocities. At the instant I turn around, I am changing my velocity at some rate. There's a change in velocity, there's an acceleration, while at that instant not moving. I would tell her, good question, but she's gone. Maybe she's mad at that answer. Other questions, stuff that you think does not click. Great. What does it mean to increase? What is an increase from one number to the next? Let me ask this. If I go from -5 to -1, have I increased or Google form? If I go from -5 to -1, question J. If I go from -5 to -1, have I increased or decreased? Let's see what the class thinks as a whole. If you increase, the number gets bigger. Is -1 bigger or is -5 bigger? From -1 to -5, which is bigger? Do I increase when I go from -1 to -5, or do I decrease? Is -5 bigger or is -1 bigger? -5 to -1. Is that an increase or a decrease? Thank you. -5 to -1. If I go from -5 meters per second to -1 meters per second, have I increased or decreased my velocity? For dog's sake. Okay, let's look at the Google form. Increased, 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 decreased, increased, decreased, increased, 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 decreased, decreased, increased, decreased. Whoo-wee! You are split in half. Again, I am going to rephrase this as numbers increase if they get bigger. Numbers decrease if they get smaller. Which number is bigger? I claim greater than, less than. I claim that -5 is a smaller number than -1. It is an increase to go from -5 to -1. Mathematically, if you go from left to right across that number line, you are increasing. You add a positive number to -5 in order to get to -1. Look, here's a number line. 0, 1, 2, 3, -1. I'm not going to draw all of this. If I go from -3 to -1, which direction do I go? I have added a positive number, yeah? Have I gotten faster or have I gotten slower if I go from -5 meters per second to -1 meter per second? Slower. In each second, I am covering less displacement. I am going in the negative direction slower. Has my speed increased or decreased? If I go from covering 5 meters per second in the negative direction to covering 1 meter per second in the negative direction, I have gotten slower. My speed has decreased. Speed is the absolute value of velocity. Speed is the absolute value of velocity. -5 is to the left on the number line of -1. If I take the absolute value of -5, that is to say 5, that is bigger than the absolute value of 1, which is to say -1, which is to say 1. 5 is a greater number. 5 is to the right on the number line of 1. Duh, right? So speed increasing and velocity increasing are different things. This goes to the crux of why I said a positive and negative acceleration do not correspond to speedy uppy and slowy downy acceleration, respectively. Your velocity is increasing if and only if your acceleration is positive. That does not mean speed is increasing. Your velocity is increasing if and only if your acceleration is positive. That does not mean speeding up. Let me draw a graph. Here is velocity. Here is time, yeah? Shoop. Slow positive velocities, yeah. Medium positive velocities, yeah. Bigger positive velocities, yeah. Am I speeding up or slowing down? Speeding up. Is that slope positive or negative? Positive, great. I can speed up with positive acceleration. What about now? I am moving at -5 meters per second, -4 meters per second, -3 meters per second. Am I going faster or slower as my numbers approach 0? If I go towards 0 meters per second, I am getting slower. Again, if you're moving at 0 meters per second, you're at rest, you're not moving. The smaller the absolute value, the smaller the magnitude of your number, the closer to the velocity equals 0 on the vertical axis you are, the slower you're going. This is slowing down, this is speeding up. What's the sign of my slope? Positive. You slopey uppy. It doesn't matter how high you are, you slopey uppy. Yeah? Any slope that is above horizontal, that's going up. The values are increasing. The values of velocity are increasing. But velocity is trending towards 0, means that the speed is trending towards 0, mean I'm slowing down. So here's an example of velocity increasing and speed increasing. Here's an example of velocity increasing and speed decreasing. God's sake, velocity increasing, speed decreasing. I should say properly there. I say that a number increases if along the number line it goes to the right. And a positive slope does not necessarily take you to bigger magnitudes of number. What is the change in velocity if I go from -5 to -1? What is the change in velocity? What is the change? What do I have to add to initial to get to final? -5 to -1. Final minus initial is 4. I am going up from a negative number to a less negative number. Yeah? Positive acceleration there. -5 meters per second to -1 meter per second. I add a number. I am getting closer to 0, so I am slowing down. 1 meter per second to 5 meters per second. Am I adding to 1 to get to 5 or subtracting? Adding or subtracting from 1 to 5. I add a positive number. I am increasing the magnitude of my velocity and increasing the magnitude, increasing the speed. So here are examples of positive acceleration. You can speed up, you can slow down. Either way, you have a positive acceleration. Negative acceleration. What's happening? Am I getting faster or slower? What's happening now? Am I getting faster or slower? Which direction am I moving here, by the way? I'm moving, say, in the ordinary coordinate system, up, down. I'm moving upward. My V numbers are positive. My positions are being added to. I have positive upward velocity that is getting smaller and smaller. I am moving up but slowing down. Velocity is positive, so I'm moving upward. Velocity numbers are getting closer to 0, so I'm slowing downward. Do you see that? Okay. How about here? Am I getting faster or slower? Faster. My velocities are negative and getting negativer. My magnitude is increasing. Here's -1 meter per second, -2 meters per second, -3 meters per second. What is the change if I go from -1 to -2? What? Oh, no. No. What do I have to add if my initial is -1 and my final is -2? The change, final minus initial, -2 minus -1. How do I subtract a negative, yo? If I take away some of your debt, I have increased your net worth, yeah? -2 minus -1 is the same thing as -2 plus 1 is the same thing as -1. My change is negative. I am going down the number line. My velocity values are decreasing. Am I getting faster or slower? Faster. Negativer and negativer is faster motion. So I want to put this together here. Velocity decreasing. And since I'm approaching the horizontal axis, I'm going to write it out. Speed decreasing. Velocity is still decreasing. You're going down, just like you. But I am getting further and further from being at rest. Okay? What is the slope of this line? Positive or negative? Negative. What's the slope of this line? Oh, that should be louder. Negative. Yeah? If you go down as time goes on, if my value decreases, time goes on and the line goes down, no matter what its value, positive or negative, no matter how high up or low down, a hand this way means that your slope is negative. Okay? I am saying the same thing in 5 different ways. Do you recognize that this is, I'm saying one thing in 5 different ways? 3 different ways. Slope is negative. Acceleration is negative. Slope of velocity here. Slope of velocity is negative. Acceleration is negative. Decreasing velocity, all equivalent. Does not mean, again, it does not mean that you are slowing down. You have to look. What you can say in general, your general conclusion, if velocity and acceleration are both positive or both negative, then you speed up. If your velocity is positive and your acceleration is negative, or your velocity is negative and your acceleration is positive, if they have different signs, then you slow down. Again, you might want to write this and think about it. If acceleration and velocity have the same sign, if you add to a positive, if you subtract from a negative, you're speeding up. And if you are subtracting from a positive or adding to a negative, you're slowing down. If acceleration and velocity have opposite signs, that's a slowy. Turn to your neighbor and discuss for 2 seconds. All right, that's time. Question me? This is harder. I expect every day you should get a little smarter. Every day it'll get a little harder, hopefully at the same rate. Or you should get smarter faster than it gets harder. As you learn, you'll have more to build on, but there'll also be more to know. So what I'm saying is you should have questions. I bet dollars to donuts that not all people in here understand what's going on. I'll ask. What is always increasing? Don't say it. Slope is not necessarily increasing. Increasing slope means the tiltiness is increasing. Slope is always positive if acceleration is positive. So hey, this is something that is also a very common oops. What is my slope doing? Is my slope increasing or decreasing? No, my value is increasing. My slope, this be a line, baby. Slope is constant. Y equals constant x plus constant. This is straight line. This is even straighter than I am, eh? Yeah? Slope is a single number here. As I go along from left to right, my hand is not tilty-tiltying more. My hand is tilted up, so slope is positive, but my hand is not changing its tilty-tilty, so the slope is a constant positive number. Be careful. The value is increasing. The slope is constant positive. Yes, I know it's hard. Be precise with your language, though, and never say it again for the rest of your life when you're talking about physics. You'll get there. Precision of language begets precision of thought. Question me. Yes.
Your position, or if it's going from like the zero position down even more to the negative, so forth.
Do you hear that?
How the line.
Every word she said is correct. Good. You got it, I think. Negative velocity don't tell you where you are. It tells you which direction you're going, how that position is changing. Negative acceleration does not tell you which way you're going. It tells you how rapidly that velocity is changing. Okay. If this does not immediately click in 2 seconds, okay, we're spending 3 whole class days on this. But work at it, baby, work at it. This is not going to pop into your heads just because you sit there and let it wash over you. Physics by osmosis, no worky. Sketch on your graphs. I can't put these, you can't put these in Google Forms, but sketch in your graph real fast. If these are velocity graphs, sketch me a negative velocity with a positive acceleration, positive velocity with a positive acceleration, and negative velocity with negative acceleration, respectively. You're gonna have you turn to your neighbors and argue about it. It's all about value versus change. Turn to your neighbor. Show me results. Argue about it. Help each other out. Are you ready? This class sucks, but it's getting better. Hopefully. Pew! My negative rate my professors are negative, but the slope is upward. I hope. This class is great. I love it, and it's getting better. Woo! Positive numbers getting positiver. Velocity positive above the horizontal axis. Acceleration, slope of velocity, positive. Positive is going upper and upper. Question? Graph of position, acceleration is curvature. Graph of velocity, just slope. Velocity is negative. This class sucks. Acceleration is negative. It's getting worse. Shoop. Last chance for questions about foundation. Yeah, in the back. Sure. Yeah, that's good. Last, remember, I want you to go back and forth between English, graph, math, right? Physics equation. So convert 4 things to and from any other of the 4 things. Faster or slower as time goes by. Slower, faster or slower as time goes by? Faster or slower as time goes by? Moving up or down? Object has a negative velocity, moving downward. Downward and slowing. Object moving downward or upward? Upward. Upward and faster. Upward and upwarder. Moving upward or downward? Velocity values are less than 0. Velocity numbers are negative and getting negativer. As time goes by, my V's are going down. This is downward direction of motion. Downward, faster and faster. Looky, looky. If the line touches the horizontal, you are not moving. If the line is close to the horizontal, you're moving slowly. If the line is further from the horizontal, you're moving fastly. If the line is below the horizontal, you're moving down. Line is above the horizontal, you're moving up. That's all there is to it. That's all, he said. I swear to God, though, swear to all the gods I don't believe in, this can click, this can make sense. Push until you get it. Okay, now here are 8 million homework hints. We have just spent significant time, because I think it's one of the biggest foundations, on connecting plus and minus, V and A, to the ideas of faster and slower. You must be able to, for the homework, connect a verbal description to a sign of velocity and acceleration. How do you feel about this? Yes, no? I'm going to cycle back to it at the end and allow you to make another set of questions. If I give you a table, do you know how to construct a graph? If I give you a table of positions, can you graph position versus time? XY coordinates, easy peasy. Do you know how to find velocities given a position graph? How would you get velocities if I tell you positions? Do it. Here, tell me if you get this right or wrong. It's hard to see your graph, but if I tell you, I don't know, X, T table here, I start from 1, I usually put the independent variable on the left. If I go from at 0 seconds, 1 second, 2 seconds, if I go from 3 to 5 to 6, graph for me the velocity versus time graph. What does that look like? Kyle, one more. 6.5. Help each other out. Turn to your neighbor and get disgusting. Get discussing. You get an A. So what you gotta do is try to figure out the slope for it. So like y1 minus 1. Why should minus y1 over x2 minus x? Yeah. If you're done, also find out what you can do about acceleration. If you're done early, I'm going to give you another 30 seconds. Play with the acceleration. What can you find about A? Is A positive? Is A negative? Okay, do you know the way? Here is the way. What's velocity's equation? Fundamental defining equation. Delta x, change of position, over delta t. For each of these time intervals, from 0 to 1 second, what's delta t? 0 to 1 changes, I sure hope you see that the change is 1. What's delta x here? How much do I change when x goes from 3 to 5? 2. From 3, initial, to 5, final. Now, properly, I would say that this velocity is somewhere in that time interval 0 to 1. I don't know that's at the beginning. Screw that. Let's keep it simple. I'm going to assume that at 0 seconds, my velocity is taking me steadily from 3 to 5. Okay, from 5 to 6, what's my rise? What's my run? Rise over run? Uno. From 2 to 3, what's the downstairs of the fraction? 1. What's the upstairs of the fraction? And I'm going to say I don't know after time 3 seconds because I don't know how it's changing thereafter. So if I'm graphing V versus T, this looks like at time 0 I go at dose. At time 1 I go at 1 meter per second. Time 2 I go at half a meter per second. And then if I want to do the algebra 1 thing, I can draw connecting lines. Is velocity positive or negative? Positive values. Looky, looky. 2, 1, 1/2. Those are positive numbers. What does positive velocity tell you in the up-down system? It's going upward. I'm going upward. First, I'm going positive 2 meters per second, positive direction. And I'm going upward at 1 meter per second. Yeah? Am I speeding up or slowing down? I'm slowing down. First, I was moving at 2 meters in each second. Then, over the next second, I moved a smaller distance. I'm slowing down while moving up. Is my acceleration positive or negative? Google form. Is my acceleration in this example, this is Google question K, is my acceleration positive or negative? Look at how V is changing. Google form K, is my acceleration positive, negative, or 0? Oh, good. You guys are getting it. You guys are getting it. Good. Holy cow. Like, not just 90%, 95% here. Acceleration is negative. Acceleration is negative. My V changes from 2 to 1. That is a change of -1. From 1 to 1/2. My acceleration is -1/2. What do I have to add to my initial to get to my final? Negative numbers. Good. Okay, so you can construct velocity given position time, and you can reason about the sign of acceleration from that graph. Now how about I construct an acceleration graph out of this velocity graph? Can you do that? Ready, set, go. Try. How do I go from this to graphing acceleration? Crudely. You don't have to be perfect, like I am. Okay, here we go. Your graph should be negative below the horizontal axis because what we just said was acceleration is negative. Moreover, your acceleration in this case, given this table, your acceleration is not constant. I will not give you homework questions where acceleration is changing for now. Not for a while. Not unless I'm just asking you to do a crude sketch or recognize what roughly it might be. Acceleration will usually be constant. It might go from a horizontal value here to a horizontal value there, but it's still it wouldn't be a slopey. Okay. So how I did this, I looked at time 0. How did my velocity change? He was -1. The acceleration would be -1 divided by time interval -1/1. Slopey of velocity gives me the value of acceleration. Okay. Let me give you a simpler example that we'll do a little bit more with. I'm going to give you a velocity graph that is more interesting. You did something very similar to this in lab. Let's just look at a little bit of this. I'm going to say this is time interval A, time interval B, time interval C, instant D, and then thereafter is time interval E. Turn to your neighbor and discuss for a brief second, what's going on physically. Practice describing moving forward, moving backwards, speeding up, slowing down, moving steadily, blah, blah, blah. They're in technically a negative velocity. They're going back down. The instant t velocity is at 0, and there's no explosion. So at c, there is acceleration, but the velocity is negative. At e, the velocity is negative, and speed is positive, or like the acceleration is positive. No, acceleration. Okay, hopefully that helped review. Here's the answer that you should have achieved. Speeding up, moving upward at a constant speed, slowing down while moving up, turning around, speeding up while moving down. Again, velocities are positive, moving upward, velocities are negative, moving downward. Velocities close to horizontal, slow, velocities far from horizontal, fast. I am speeding up, I'm going away from 0. I am accelerating in the positive direction while moving upward. Value is positive, acceleration, that's the slope away from 0. I am moving at a steady velocity, moving uniformly, smoothly, steadily in the positive direction. I am still moving in the positive direction. My object is moving upward, but my velocity is decreasing. I'm moving upward at a slower and slower speed. I'm moving upward at a slow speed. I'm moving downward at an increasing speed. Slowing down, speeding up. What happens between moving upward and moving downward? As you turn around. This is the highest point I reach, the most positive point I reach. I have ended all of my upward motion and I'm about to start going down. This is your peak position. Well, it's the time at which you reach your peak position. Now I'm going to construct an acceleration graph from this. Bang. Shazam. What's his slope? Positive. Value is positive. Is the slope changing? Slope is not changing. Hmm? It's a constant positive. This part A is a line. Straight line. So the value of A does not change as long as the slope is not curved, and it won't be for the examples I give you. As long as this slope is not curved, velocity is straight, means acceleration is horizontal. Velocity is horizontal, acceleration is 0. There's no rise. It does not going up. Velocity is not going up. Velocity is not going down. Velocity is not changing. You are not accelerating. This whole time interval, C, D, and E, I am accelerating in the downward direction. I follow a straight diagonal line. My slope is not changing. I have a steady, constant, horizontal acceleration. All this is slope, baby. All this is distinguishing precisely. I have said the same thing now steadily 15 times. The only idea that we're manipulating here is different ways of seeing and representing slope of something versus value of something. What something is versus how it is changing. That's all we're doing mathematically. We are representing this as graphs, representing this as English, representing this as numbers. But it's all one idea. Look for that pattern. This is why I don't know much. I don't know a lot of things. But the few things I do know, I recognize the patterns within them so I can hop from one thing to the next thing to the next thing easily. I recognize the similarities in different things. Strive for that. Look for the simplicity. Physics is simple once it clicks. Almost done with class, almost done with my hints for you. Do you guys know what G's are? I'm pulling 3 G's. What does that mean? My plane is accelerating at 10 G's. Oh, I'm going to black out. Gravitational pull itself don't change. It is compared to your gravitational acceleration. So if I accelerate at 1 G, that's saying I'm accelerating at the same rate I would if I fell. If you fall with constant acceleration. That's next week topic, but here we go. By the way, if you fall at approximately with a changing velocity of 10 meters per second downward. Every second, you pick up 10 meters per second of downward velocity. If I am accelerating at 2 Gs, what's my acceleration in meters per second squared? Twice as fast as negative 10 is negative 20. If I'm accelerating at negative 3, at 5 Gs, what's my acceleration in SI units? 50. Negative 50 meters per second squared. Usually when we're talking about your acceleration in G's, we don't care the direction or the direction is implied. So very often we're just talking magnitude. If I recall correctly, in the problems that I ask, don't include the minus sign. They will ask you for magnitude of acceleration measured in G's. If my acceleration is 37 meters per second squared, Google form L. If my acceleration is 37 meters per second squared, answer, how many G's am I pulling? A is 37 meters per second squared. Find A in G's. Think carefully, by the way. Think carefully. I just told you how to convert from G's to A's. I'm asking you to think about how to go from A to G's, from SI units, meters per second squared, to G's. How many times 10.0 is 37? How many tens are there in 37 meters per second squared? Z Brooks, drop the minus, like I was saying. What is the magnitude? Screw it. Screw the fact that the free fall acceleration is downward. G, I'm going to say if we're talking about G factors, acceleration in G's, we're just talking about magnitude. Yeah.
Gotta go into the negative or positive acceleration, or is it general when we're talking about G's?
Just G's. If I'm talking about G factors, I'm going to be asking about magnitude. Okay, the correct answer. How many tens can I fit into 37 is 3.7. There are 3.7 tens in 37. So I would express this equivalently as 3.7 G. Yeah? If G is 10 meters per second squared, 3.7 times 10 is 37 meters per second squared. Yeah? You see? Yeah? We've done a fair bit of thinking. This, hopefully, is the easier side. Clicky? Okay. Question M, what's a millisecond? Express milliseconds in seconds. No, let me say one is boring. 3 milliseconds in seconds. Oh, I should have just written MS and asked you what that means. Oh, missed opportunity. Express in decimal, please. I'll tell you, this is something on the order of magnitude of blinking your eye, I think. .3 Gs, what the what? Seconds and Gs measure different things, my friend. Okay, this is an important thing. I will not ask you to convert feet to meters, miles to hectares, squares, whatever. I will ask you to know the difference between a milli, a centa, a giga. No, I don't think there's a single problem that I give you that's a giga. But you need to know mega through maybe micro. It's only 4 things. Mega millions, micro millionths, kilo thousands, millis, thousandths. Oh, centa. Everyone uses centimeters, right? Centa is hundredths. How many cents are there in a dollar? 100. Duh, same thing, right? Okay, 3 milliseconds. Milli means thousandth. Thousand. Great word. How many decimal places is 1/1000th? Uno, dos, 3. Yeah? If I shift by 3 decimal places, which direction do I shift? Is a milli a long time or a short time? What did I say? It's like something on the order of magnitude, I think, of blinking your eye. Not 3,000 seconds. Sanity check that sucker. I had a number of people say 3,000 seconds. That's a fraction of an hour. Watch out. Okay. If I give you velocity graph, if I tell you velocity is this, that, or the other, can you get displacement? If I graph velocity as 5 meters per second for 3 seconds, can you tell me how far you've displaced? If I tell you Google form, velocity is 5 meters per second, you move for 3 seconds, what's your displacement? Google form N. Properly, there should be a space, by the way. Okay, let's think about this. What does it mean to move for 5 meters per second? In the first second, how far do I move? In the second second, how far do I move? Third second, how far do I move? Does it make sense to divide? Is 5/3 of a second more than 5 plus 5 plus 5? Okay, so do not jump for 5/3. If I move at 5 meters per second for 3 seconds, I multiply to get that. If I show you a graph where v is first this, then that, can you find displacement? Google form, question O. I'm going to give you a graph. Here is velocity, here is time. -2 meters per second for 4 seconds. And then I'm going to jump down to -3 seconds for another -3 meters per second for 1 more second. What is my total displacement over this 5-second interval? Dot diddly dot dot dotters. That looks correct.
Don't work it out.
Okay, let's reason about this. 4 seconds. Each second, I move 2 meters per second, at 2 meters per second. How far have I moved in this 4 seconds? 8 seconds. 2 meters, 2 meters, 2 meters, 2 meters in the negative direction. Displacement in the first 4 seconds is -8. Then I hop down, and for 1 second, I move at -3 meters per second. How fast? How far? I move another -3 meters. Final answer, -11 meters. Yeah? Yeah? Okay. I'm going to give hints in a different way over different problems to the 430 section. The first part of the 430 recording will be the concepts of what we did, and a fair bit of the signs, like I think is the most trickiest parts and questions. If you are struggling on the homework, I encourage you to watch the second half of the 430. I will include more hints in there that we didn't get to. I love each and every one of you. You are all awesome. Get out of here.